All right, 3B7 Part 3, we're going to focus solely on intervals of positive and intervals of negative, another section that caused some people some trouble when we looked at them with linear functions. So we're going to look mainly at intervals of positive and intervals of negative with quadratics now. Still working with those same two examples though. Interval of positive is the domain over which the function has a positive output. Anytime we ask you for an interval of something, you can pretty much bet that it's going to be a domain where something is happening, a domain where it's increasing, a domain where it's decreasing. In this case, a domain where it's positive. I'm going to go ahead and define interval of negative as the domain over which the function has a negative output. Basically, that means tell me what x's you can plug in to this equation or to this function and get out a positive y value. So when I look at this function, first of all, let's go ahead and draw the arrows that we know should be there. I'll go ahead and do that on both the examples. So it's there. When I look at this function, if I think about plugging in a -4 over here, then I know that my output is going to be up here. If I plug in a -3, then I know I'm going to be right there at that 0. Anything below -3 is going to be up above the 0 line. When I get to anything bigger than -3, like -2, suddenly my y value is negative. When I'm at 0, my y value is negative. When I'm at 1 here, that's where I hit that x-axis again, and suddenly it jumps back into positive. Because if you think about the y-axis, my positive values up here is 1, here's 1/2, here's 1.5. All the values above that x-axis are positive. Below that x-axis, here's -1 and -2 and -3. So if I'm getting anything along this section of this graph, then it is negative. Well, the domain for that section is going to be my interval of negative. If I'm getting anything of this or this, those are my positive sections of the graph. So for the interval of positive, I'm going to give the domain of this part of the graph and the domain of this part of the graph. So what that's going to be is x goes from -infinity to -3. Because remember, on this one we're counting every other one is 1. So there's -1, there's -2, there's -3. So from -infinity all the way up to right here, this thing is positive. So to -3. Then it flips over and becomes negative. At -3 it's at 0. 0 is kind of a bridge number. It's neither positive nor negative. So at -3 it flips over and starts becoming negative. And it stays negative all the way until I get right here, which is +1. Over here would be 2. So an interval of negative is from -3 to +1. Again, just looking at the x values for which I can plug values in. That means anything between -3 and 1, if I plug it into this function, I'm going to end up with a negative output. Anything smaller than -3, so you could also just see it written like this, if x is anything smaller than -3, then I'm going to get a positive output. I'm also going to get a positive output if I go from 1 to +infinity, because starting back at 1, I'm above that x-axis again, and I'm going to remain above that x-axis no matter how big x gets. We know that if I go way over here, it's just going to be all the way up off my screen. So from 1 to infinity, it's also a positive interval. So the other way you could see that written is when x is greater than 1. Okay, so for this particular one, we have 2 intervals of positive, just 1 interval of negative. Over here, we're going to do the same thing for this example. We're going to look at for our intervals of positive and our intervals of negative kind of in tandem. So first I'm going to highlight again. My interval of negative, this thing is negative all along here, and then it starts being positive for a while and then becomes negative again once I hit that x-axis again, and it continues down forever. Its interval of positive is just this little section along here. Okay, so when I'm writing that out, I'm going to start with this first section because I like to just start at the beginning of my domain and work my way over, not necessarily do all the positive and then all the negative. So for my interval, my first interval of negative, when I first start this domain, I'm at negative infinity, and this is a negative output. I'm below that x-axis. So it's negative infinity, and it continues to be negative until we hit the x-axis, which happens at about 1/2, I think is what we decided. So you can say either 0.5 or 1/2, whichever you prefer. Okay, the other way you could write that is just x is less than 1/2. Okay, at 1/2, it flips over and becomes positive. So I'm going to say this is positive starting at 1/2 and continuing until 3.5, right here where we flip again. So 3.5 or 3.5 or 7/2, however you want to write that. That's my interval of positive, and that's the only time that it's positive. So now I'm going to flip over and I have another interval of negative, because starting at 3.5, we start being negative again, and we continue being negative no matter how big of an input I put in, so to positive infinity. So if you look at the intervals of positive and intervals of negative, together you should have all numbers covered from negative infinity to positive infinity. With this example, we start at negative infinity, we go to -3. At -3, it flips over to being a negative output, and it stays negative until we get to that 1. And then at 1, we go back to being positive up to positive infinity. This one kind of goes the other way. So that's it for intervals of positive and negative. I'm going to end this here, and then we'll talk about end behavior in a next video.